So we are on the 16th problem in order, which is problem number 14. So this one honestly is a lot of work for one problem. Just because you have to check different things, which I think is probably the only reason it's this high. So I'm going to kind of go out of order as far as answering this one, because we can look at some of them really easy. 100 people were interviewed and classified according to their attitude towards small cards and their personality type. The results are shown in the table below. You can see right here that there's 100 total people that were interviewed. 60 of them had type A, 40 were type B overall. Overall, their attitudes, 37 positive, and so forth. So I'm going to look at the ones that actually say 100 in them because they're easy to look at. For each personality type, more than half had a neutral. Well, more than half of 100 is 50. So more than 50 had a neutral in every single personality type. Number one, that's not possible. And we can look at it and see that neither one of those is 50.
Miss Lemon, I wasn't here yesterday. What are we writing down?
You'll write. Just show her one. So like you write down which number we're on, and then anything we write about that problem going over it. But make sure that it's very clear that like this whole section is with this number like right off to the side. Really obvious that I'm gonna go through it, and then you'll go back and do the ones you did yesterday. For E, again, it says more than half of the 100 respondents have type A and have a positive attitude. How many in the chart have type A, or where is type A and positive attitude? Is where they what? Go ahead and tell me what number it is. 25. It's where they overlap. Well, that's not more than half of the 100 respondents. So that already knocks us down to 3 to actually have to work out. And all 3 of these, I think, stem from the same problem, so I don't have to do as much math as you think you do. Of the 3 attitude groups, the group with the negative attitude has the highest proportion of type A. So I want to find the proportion of type A for each of the 3 personality types. So to get this one, I would do 25 out of 37, which gives me 67.6%. Here I do 11 out of 20, which gives me 55%. Here I do 24 out of 43, which gives me 55.8%. So that's the proportion of type A. So of the 3 attitude groups, the group with the negative attitude has the highest proportion of type A. That's not true. Positive has the highest proportion of type A. B says of the 3 attitude groups, the group with the neutral has the highest proportion of type B. Well, this gets really easy to do because if these are the proportion of type A, then I can just do 100 minus to get the proportion, proportion of type B. So here's 45, 44.2, 2.4. So of the 3 attitude groups, the group with the neutral attitude has the highest proportion of type B. Is that true or false? True. And then just to double check, the proportion that has a positive attitude towards small cars is higher. So the proportion that have positive attitude toward cars is higher among people with type B than it is with type A, which we already have all that information there to be able to see that that's done. I just don't love this because I feel like that's a lot of work you have to do for one little problem, but it's trying to test a bunch of different things. Just to talk about more than just this problem, would it change if I switched? I'm trying to think about how to do it. Yeah, it's hard to talk about. With just looking at option A in general here, what are we looking at as our? It's not a good problem. I want to talk about like givens and switching which givens which. That's really not an easy problem to talk about that with. I guess I can talk about this as a completely different problem. Just to kind of touch on this fact, just fraction number. Proportion of positive attitude given type A would be whatever what. So given that it's A, it would be out of what? And then where they intersect is 25, as opposed to this one would be what instead? Where I switch them. So just kind of going over the fact that it matters which the given is in each problem. This problem didn't really set it up.
Wait, huh?
This is a side. This is me just talking about something completely different.
Okay, yeah. Okay.
And again, just like I said before, if you think of anything along the lines that you want to bring up, I'm more than welcome to go slow.
Were you telling it in random order?
We're going in the order of most missed to least missed. So hopefully by the time we get to the end, we'll go a lot quicker. A city is interested in building a waste management facility in a certain area. 100 randomly selected residents from this area were asked, do you support the city's decision to build a waste management facility in your area? Of the 100 residents interviewed, 54 said no, 4 said yes, and 42 had no opinion. A large sample confidence interval, p hat plus or minus z star square root of p hat 1 minus p hat over n, was constructed from these data to estimate the proportion of this area's residents who support building a waste management facility in the area. Which of the following statements is correct for this interval? I'm going to go ahead and go straight through these. So the confidence interval is valid because a sample size of more than 30 was used. What is this talking about? And I want this written on your paper somewhere. What kind of problem is this? One word. Proportion. So what should I definitely write about this? So it and that's one constant mistake I've noticed throughout the year, this year, that's not always an issue is people trying to keep using central limit theorem for proportions. So that's not something we're dealing with here. It is valid because each area resident was asked the same question. Were they all asked the same question?
Yeah.
Yes. Is that good?
No.
Does that make the whole thing valid? No. So there might be other issues there. So maybe that's one that I wouldn't mark out immediately, but I'm going to keep going. Confidence interval is valid because no conditions are required.
No.
Is that correct?
No.
This confidence interval is not valid because the quantity of n times p hat is too small, and the confidence interval is not valid because no opinion was included as a response category.
Do we know what the p hat is?
Yes. How many options are there? How many possible outcomes are there? 3. How many do we need in order to do this? 2. But the problem says,
Which outcomes are you talking about? Okay.
so what are we defining as success?
Yes.
So what is left?
No.
So what can we do with those? So it either is yes or it's not yes. So this is one of those where it starts out as 3, but you can reduce it to 2. And a lot of people are going to pick E because of that. But that's not an issue because we can, even though it starts with 3, we can reduce it to 2. It either is a success or it's not. So now going back and talking about D, how do we determine the n times p hat?
How do you get your p hat?
So what is n?
It's just our
Right, so it's our number of successes. What is n? And then technically what is p hat? So this is one of those where it gave us the number of successes. And how many should that be? 10. But a lot of the ones that we worked yesterday just happen to be ones that were, of course, the tough problems. There's a lot to them. I'm hoping a lot more today are going to have things that I want to write like this that are general statements that apply to issues that we're seeing in the problem. And number 29 is our next problem. When forming a test of significance about a population mean, a t-distribution instead of a normal distribution is utilized. Which of the following is most appropriate explanation for this? Some of you are going to get confused by the wording of that problem, and I get that. We can go super easy here, and let me back up before I read the problem. It says we're going to test. What is my general equation for, if I'm considering Z or T, I know that I'm dealing with a what? I'm dealing with something, not something else. I'm dealing with means, not proportions. So what is a easy equation that deals with a test for Z? Like Z equals what? Alright, so just because that, I'm going to write mu just so we don't get confused, which I could go with both of those. As opposed to when I'm doing it as a t test statistic, I do it as what? I don't want to think about it that way. Let me back up. When we write this and we write a footnote above it, a star above it, we use this because why? And here we would say, sorry, I started out on the long route and decided to go the easy way. So, why do we use T? Because we don't know sigma. But I think the wording of this part probably threw some people off and didn't go as direct thinking as this. So the sample size is not large enough to assume that the population distribution is normal. Does that have anything to do with Z and T? not really. Sample does not follow normal distribution, or we need normal for both of those. There's an increase in the variability of test statistic due to estimation of the population standard deviation. Let me look, I'm gonna go backwards. Population standard deviation is too large. It's never gonna happen. I think people literally just did not read this problem. The sample standard deviation is unknown. Is that true or false?
Oh, is that what sig? That is what sig. Wait.
This is what? So this would mean we use sigma because we knew it. If not, if we didn't know sigma, we'd have to go to S. So,
Wait, what?
if we have a sigma, we use it. If we don't, we have to resort to using this, right? So, this is not saying that. This is saying you don't know S, so you would use something else. But what actually happens, and we've talked about this, but you don't have to be asked it this way with this portion. We're not as sure that the population or that the population standard deviation is that because we've only taken it from a sample, so we have to estimate due to possible error. We don't talk about that part as much in our class, but it is the fact that we have to estimate sigma. The sigma is unknown. At 39. The weights of a population of adult male gray whales are approximately normally distributed. With a mean of 18,000 and standard deviation of 4,000. So all of that first sentence is talking about adult male gray whales. Second sentence all switches and talks about adult male humpback whales.
And why are you writing sigma instead of S? How do you know sigma?
Overall, it doesn't really matter at this point. It doesn't say anything about a sample. Oh, it does for population. So you know you go with that one. X bar and S go with the sample. Mu and sigma go with population. So the weights of population of humpback male whales are approximately normal with a mean of 30,000 and a standard deviation of 6,000. We talked about this yesterday. If it says normal, that means we can use normal approximation, which means we can use yellow sheet, which means we can use anything with z-table. A certain adult male gray whale weighs 24,000 kilograms. And I want to know, this would have the same z-score as a humpback whale of what? So I need to directly relate this 24,000 to which group? What kind is this one? So you actually start here. So this is my what? Like a symbol. That's just our X. Like that's our individual value. So what am I going to do with these? What equation can I use with those? So 24,000 minus 18,000 divided by 4,000. So what is 24 minus 18? So I've got 6,000 divided by 4,000, which leaves me with now this is a typical type problem. It says now what weight humpback whale would have this exact same z-score. So I'm saying my z-score is 1.5,
Equals that.
and this is what I'm solving for now with those numbers. And then so all I'm doing is algebra to get out of that. What's the first thing I do there? Multiply by 6,000. So what's half of 6,000? 3,000. So 3,000 plus 6,000 gives me what? 9,000. And I'm adding 30,000 to it. So my answer is now again, just like yesterday, I'm explaining the correct way to do it, but sometimes I'll go back and explain some things about
How'd you get 39?
math here would give you 9,000.
Oh,
For some reason.
some reason. Oh, I did it like it was 3,000.
Oh, because I said 3,000 out loud. So now backing up, if you had no idea where to go with that, I know that this male great whale is how is it related to the group of gray males? It's bigger. So if I want to see how this one is compared to gray whales, what would be compared to humpback whales? Well, I know that this is the average, so my answer should definitely be what? Bigger than that, which would eliminate you to just two answer choices. So again, if you get stuck, you should be able to think your way through a piece of it. We're comparing this to the gray whales, right? So I know that this number relates how to that whole group of gray whales. It's bigger than the average.
Okay.
So if I'm going to see what humpback whale would be the same,
It'd be big. Okay.
it's bigger than that average, at least gets you down to two answer choices. 25. Alright, so in the table it shows height in inches and the arm span in inches for 10 randomly selected high school students. Which of the following significant tests should be used to determine whether a linear relationship exists between height and arm span provided the assumptions of the test are met? There is one very obvious piece of this that is going to tell you the answer. What in that entire wording really directs you towards the answer? If I am testing this, there's only one way I can do that. My answer is what?
What do the others look like?
That's what I'm going to go back through. So now let's talk through the whole thing. I have two different variables. Are my variables categorical or quantitative? Quantitative, so numerical. What do I know about, so like let's pretend this question isn't here at all. If that question weren't there at all, what's really specific about the way this is set up?
Which was quantitative?
Both height and arm span are both numbers. If I'm just thinking in general, like maybe back a couple of chapters, 2 chapters, what's really specific about the way that chart's set up? So, what do I know about 65 and 67? So if this problem weren't here and this weren't what we were asking, which would mean if we were looking at it, that kind of problem without this question, this would look like a what? A matched pairs kind of problem, because each student has both of their values written together. So this would definitely not be a two sample anything. We would switch it to matched pairs. Why is it not chi-square goodness of fit? What would a chi-square goodness of fit look like?
One row.
And what about what would that look like? I'm trying to think about how to ask you this without telling you the answer. Visually, I would have a something in front of me, which is not what this is. Like, this is a table of data, but this is a specific table.
I don't remember the chi-squared one.
This is one row of categories. So, like, blue, yellow, red. What would this one be? So how many variables are here? One. How many variables are in a chi-square test of independence? So what would it look like? Does that make sense? So again, even though this, I'm talking about a whole lot more than problem 25, you can be writing this as problem 25. I'm not leaving it
When
specific
do
to
we
problem.
do chi-square?
11.
No, when do we do it?
What do you mean? Like when the problem, like what in the problem would ask us to do that? Can't remember if there's one that comes up or not. I think we'll get to one. If we don't. Then I'll come back to it later. At number 37. Dan, a trainer at the popular gym, was interested in comparing levels of physical fitness to students attending a nearby community college to those attending a 4-year college in town. He selected a random sample. Again, I'm hoping that you'd be writing stuff like this as you go along. A random sample of 320 students from the community college. The mean and standard deviations of their fitness scores were 95 and 10 respectively. He also selected a random sample of 320 students from the 4-year college. The mean and standard deviation of theirs were 92 and 13 respectively. He then conducted a 2-sided t-test that resulted in a t-value of 3.27. Which of the following is the appropriate conclusion from this study?
Wouldn't it be S, since he's using this specific method?
Okay, yeah. Do it that way. Yeah, you can do this X bar S, but that would get funny. Sometimes I just write stuff so that I can see if it's a mean and standard deviation ahead of time, like as I'm reading, and then go back and see if I need to switch it, but you're right. Because the sample means only differed by 3, the population means are not significantly different. Is that true or false? False. Because if I'm thinking, even an extreme example, if we're thinking about something like GPA, If the sample means differed by 3, would that be a lot? So there's a lot more to it than just how much they differ by. Because the second group had a larger standard deviation, their fitness score is significantly higher. Is that correct? No, you can't just use standard deviation and not compare anything else. Because the second group had a larger standard deviation, the mean of the first group is significantly higher.
Wait, why isn't it B?
Standard deviation alone isn't going to tell you which one's higher or which one's lower. That one just tells you, standard deviation just tells you how much it was. Generally. What does standard deviation talk about? The distance at what? So how much, standard deviation is how much the data, what?
It's away from each other.
It's reference over how much it varies. A measure of spread. So one of them being more spread out than the other one doesn't mean the group is higher. The p-value is less than, so I'm going to look at now, I'm down the D and E, and one of them says p-value is less than alpha is 0.05, and one of them says p-value is greater than alpha equals 0.05. So at this point, I haven't had to do any math, but now it looks like I probably have to figure out what alpha is. Possibly. So now I'm going to keep looking at wording. The mean fitness scores for the two groups of students are significantly different. Does it look like that section of the wording is the exact same in both problems? So I actually don't have to do the math here if I don't want to, but I could have and still got the right answer. So if they are statistically significant, that would mean that our what? And which one correctly matches that? Does that make sense? And I never had to do any math, but I could have. If I wanted to, it told me that that's my test statistic. But what did the problem say initially? What kind of a test did I run? Two-tail. Can't see where I put it. Let's do this out of practice. Get out your blue sheet. No, I want to do this in the calculator. Let's do this in the calculator. I can show you on the blue sheet, but I don't like using that one. If you don't have one, get one. Where am I going to go in my calculator to find something with the area for a t distribution? Where do I go in my calculator? Second distribution. I have a test statistic value, so do I go to inverse t or TCDF? TCDF. And which should get you to here. So what could I put as my lower?
Why do we use TCDF?
It told us it was a t-value. What could I put as my lower? Negative 1.99, and then I would go to upper as what? There's more than one way to do this. That's what I'm letting y'all tell me. And when I go to positive or negative? If I want to find this tail, I would just go to negative 3.27. What would I put as my degrees of freedom?
Wait, what did you put as your upper?
I'm going to put in there. What about degrees of freedom? Why is degrees of freedom funny? Or possibly funny?
It's too simple.
There's 2 of them, but what do I know about the 2 of them?
It's the same.
They're the same number, so do I really have to deal with that? No. So it is 320, so my degrees of freedom would be what? 319. So yours should look like this.
I did it negative 3.27.
Some people are going to do it that way, and some people are going to do it as 3.27 to positive 1e99. Like that. And you're going to get the same thing, because you're finding either the right tail or the left tail. And either way, when you do it, you should get this. What kind of a number is that?
It's very-
A very low number. So there's 3 zeros in front of that. And that's only one tail, so technically I have to do what with that?
multiply by 2.
Is that still going to be significantly less than 0.05? Yeah. So if you didn't look at it the way I did, you could have looked at it to see you needed to do math and then found what the p-value was and then found that it was less than 0.05 and then gone with that answer because of that. A lot of times with these problems, there get to be at least 2 different ways you can solve them. Or ways you can get to the answer, yeah.
How do you sell it without doing the math?
Just where I talked about the ends of both of them look the same. And so if it was significant, the only way if it is significant, that means p-value was less than alpha. It's like these both say they are significant. If they are significant, that means p-value is less. And so this is the only option that said that p-value is less.
Oh, it was D.
How many people miss this problem?
54% got it correct. And so we're at 54%. So from here out, we're above half the class getting these problems right. And some of them I'll start to go quicker on, but some of them will have a lot of side things I could talk about. At number 40. Five estimators for a parameter are being evaluated. The true value of the parameter is 0. Simulations of 100 random samples, each of size n, so some size that are all the same, are drawn from the population. For each simulated sample, the 5 estimates are computed. The histograms below display the simulated sampling distributions for the 5 estimators. Which simulated sampling distribution is associated with the best estimator for this parameter? There's a lot of wording in that is basically unnecessary. The true value of the parameter is 0. And we want to know which one is the best estimator. Which ones can I immediately mark out just because the true value of the parameter is 0? So I'm looking for one to mark out ones that are not what? Centered around 0. So which ones are definitely not centered around 0? And C, maybe not as obvious, maybe not terrible, but D and E, there's pretty much no chance. If I want to know which is the best estimator, what's the difference between A and B? B is a whole lot less spread out. So which one would be a better estimator? The one that has a bigger spread or a smaller spread? And I think some people just didn't look at the fact that they weren't centered around the right number. So and some of these, I don't mind, I kind of noticed y'all talking to each other yesterday during some of them. If we get to a problem like this, and you're like looking around like, what the heck is wrong with the right? I don't mind you saying something. So So like if you get stuck at one and I forgot to say something, you want to be like, what should I write here? I don't mind saying it. So this one, I would definitely write something about centered at true parameter. And what's the other thing? What's the second deciding factor we used?
Right.
And we wanted the one that's what?
Let's spread out.
All right, 26. This one's a little bit concerning. The thing that is oh no, I'm looking at the wrong answer sheet. Man, okay, people that pick the wrong answer, I could see where they at least came up with most of people come up with something. If anytime we do a standardized score, we are relating it to what of these things up here? The mean. So before I ever do anything with this problem, what kind of z-score is this? Which means I should immediately eliminate what answer choices? Ones that are not less than the mean. And I had a decent chunk pick D. I had some picks another one too, but I get that one. What's the only other thing I use? So when I find a z-score, what are the two things I use? Mean and what? So this problem should be an easy problem, but you can eliminate those two before you start it. What's my equation for this? Well, I know my z. Do I know my x?
No.
Do I know my x bar? I know my standard deviation. Oh, maybe that's what people get do it as this instead. Okay, then I'm going to talk about something else with this problem. At that point, it's algebra. You're doing 221.9 times negative 1.2. Let's do that. What's that give me?
Negative 266.1.
And then I do what at that point? Add 1045.7, and I end up getting this answer. But there's another part of this problem that I want to discuss, which I feel a little bit better about why people chose this one. Yeah. I could have S or I could have sigma as my standard deviation. What is standard error instead of standard deviation? A Z confidence interval a T confidence interval what is standard error? Why is the word error there? There is some error because we had to use a statistic instead of a parameter. So we didn't use S here anywhere, but we did here. This whole section is standard error. And it says standard error of the mean. So what we used was and whether I did mu or sigma. Do you know the difference between those two? Do you understand the difference between those two equations? If I say find the value for this person, which one would I use? The top one. If I said find the value for this group, you would use the bottom one. This is the standard error of the mean, and we are finding it for an individual. Which is why we would not use standard error of the mean, just kind of going back over why not to use that.
And when again are we using those equations versus the, like, what we just did, something like that? Like x minus mu over sigma? What's the difference?
That's the same thing. That's x minus mu over sigma. This one is x minus mu over sigma. This one's x bar minus mu over sigma.
I'm talking about the blue lines up there.
Up there. Oh, I was just writing. That one's a confidence interval as opposed to a test.
Okay.
But this concept right here is major for the AP exam, understanding if you're dealing with an individual or a sample. Technically, it always uses this equation, the bottom one, but what would that be if we're dealing with an individual? 1, so it goes away. Number 15. In study of weights of college athletes, players' weights for a random sample of baseball players and for hockey players were compared. The output shown below gives the results. And we are testing versus this, which means it is one-tailed, and we're only testing that baseball players is less than hockey players. So which of the following is the best conclusion that can be drawn from the analysis? So what things up here are probably most important for a test? Like if I'm running a test, what's going to tell me, like if I'm going to give my results to somebody else, what's the most important thing up here? A p-value was what? What kind of p-value is that? Higher or lower than what you would usually want? Higher, because it's bigger than what? 0.05. So some of them are compared to 0.05 and some of them are compared to 0.10. So it is less than 0.0, or it is not less than 0.05. It is less than 0.10. Hello? Yes. Well, thank you. Ryan, you're gonna help them. So if it is less than, is it significant or not? If p-value is less than alpha, is it significant or not? Here it is, not significant. Everybody with me there? So that can probably reduce our answers a lot without even looking at wording. So not significant should work with 0.05. If I'm at 0.10, it should be significant. So it's definitely not B. C, D, and E say is significant. It should only be is significant with 0.10 and not 0.05. So before actually reading the problem, I'm down to A and C. Does that make sense? Where I am. This one, A, says the weights of baseball players is not significantly lower. This one says the weight of baseball players is significantly higher. Which one of those is correct? Which one did I test? I did not test if baseball players was higher.
How did we test it?
And I did make this point yesterday, and I think it wasn't a huge deal, but I did make it in my other class. I do not want phones out at all while we're going over this. I'm giving you a big break for this, so I need you to at least pay attention. Number 11. This is a typical type problem, but this one I think they almost give you too much information. You kind of have to think less on this than you do in some of them. So it gives us a histogram, and it wants us to make a box plot of it. Usually, like I said, they're not going to give you this much information. It tells you that the largest observation is an outlier. Well, how do we show an outlier in a box plot? As a dot. Well, every single one of those graphs have a dot at the outlier number, so that doesn't actually seem that helpful, right? So what I do in this is look at things that are different and start there. To me, I can look at this and see the dots are in the same place. It looks like the left side's in the same place, and it might even look like the first vertical line is in the same place for all of them. Does that make sense? So I'm not going to look at that at all if they're all the same. So one thing that definitely looks like it's different is where that middle line is, and that middle line is your what? Median. It tells us that there are how many values in the data set? 26. Which means the median is where there's 13 on each side. So here I've got 10, which means somewhere in this bar is where my median is, which means it is between 20 and 30. This one's between 20 and 30. This one's between 20 and 30. This one is not. This one is. This one is not. So I can go ahead and mark 2 out with that. What's the next obvious thing that I can look at to tell what's different?
The gap
What gap?
in the right one.
So this right line, this right here, should go to the what? I'm just very generally drawing this.
To the outlier, right?
To the highest point in that is an out.
Which means actually in the data, and this is why it gave us that extra information, because it's trying to make people do the wrong thing. It calculated for us that this is where the outliers would start. Do I draw that on my graph at all? No. So the last data point that is not an outlier is something below 70. Here my line goes to 80 something. Here my line goes to 80 something. This is where it should be. So D is my answer.
What type of value was the 87?
That's telling us anything above, that's our outlier cutoff value. And that's not actually a data point. I didn't have anything between 70 and 90. So that line goes out to an actual value in the data set, not the cutoff measurement. Number 20. This one is a straightforward one, understanding what the problem's asking, or you understand the concept being asked, or you don't. Just set it on my podium up there, and then just start with us, but then go back and do them later. So automobile brake pads are either metallic or non-metallic. An experiment is to be conducted to determine whether the stopping distance is the same for both types of brake pads. So I know the problem doesn't ask this, but what is our response variable for this problem? What are we measuring?
Stopping distance.
Our explanatory variable can be broken down into treatments or factors and levels. What are the things that we are testing? So factors, I'll even break it down more than that. Factor is the generic thing that we are testing. What's the thing that we're testing? How many levels are there? Two, what are they?
Valid commentary.
In previous studies, it was determined that car size is associated with stopping distance, but car type is not associated with stopping distance. So, regardless of which car type we use, isn't going to change our what? Our response variable. But there is this thing there is something external that is impacting our response variable. Which, if we didn't account for that, we would consider that a what? We would consider this a possible what? Lurking variable, confounding variable. But we know that it is, so we, to avoid confounding, the lurking variable that changes our response variable we do what? What's the whole problem asking about? And so we block based on, and I'll draw this out in a second. We would block based on that external variable that will directly impact our response variable. So what are we blocking on? Which is the one that would impact it? Car size. And I am going to draw this one out. Y'all don't need to draw this. If I were doing a randomized block, what would I do from here? This is my population. What would I do with my population if I'm blocking? Split it on what? Car size. So we have 3. Now I have a number for each one of them. And then what would I do at that point with each one of these? To how many things? And what would they be?
Metallic and non-metallic brake pads.
And then so I do the same thing here, and then I would do this at the end so that I could see at each car type, does one of the brake types work better? Does that make sense? So this is a blocking, randomized block design. It's just asking about this portion for this question. (28) A group of students has 60 house flies in a large container and needs to assign 20 of them to each of the 3 groups labeled A, B, and C for an experiment. They can capture the flies one at a time. When the fly enters the side chamber of the container that is mated with food. Which of the following methods most likely result in comparable groups of 20 houseflies? When it says in comparable groups of 20 houseflies, we are trying to avoid what here? We're trying to avoid any of the groups being, I guess, biased for some reason. So label the first 20 flies caught as group A. Is that a good idea or a bad idea? Wow.
Because there might be something that like made them be first.
And so whether it's a good thing or a bad thing, it might be that the first 20 are the ones that are faster, better, can sense things better, and that's why they're the first 20 caught. Or it could be the ones that are easier to catch for some reason, and that's why they're all caught. But that means they're similar for some reason. So that is bad. When each fly is caught, roll a die. I'm looking at the beginning of them. Place each fly in its own container. Which fly is caught, roll a die. So that's the only one that looks like it's just dealing with straight up the first one's caught. Write the letters A, B, and C on separate slips of paper. Randomly pick one, and then assign the first 20 flies. So is this one actually any different? It's just randomly assigning which one gets it, but we still have that same issue with the first 20 flies. C, when each fly is caught, roll a die. If the die shows an even number, the fly is labeled A. If it shows an odd number, it's B. When 20 flies have been labeled A and 20 have been labeled B, the remaining flies are labeled C. Okay, maybe that one's a little bit better. Place each fly in its own numbered container, numbered 1 to 16, in the order that it was caught. Place the numbers on slips of paper, put the slips in a jar, mix them well. Pull 20 numbers out of the jar, assign the flies to the containers to those numbers to group A, the next to group B, and the next to group C. Okay, that might be okay. E, when each fly is caught, roll a die. If the die shows a 1 or a 2, the fly is labeled A. If it shows a 3 or 4, the fly is labeled B. If it shows a 5 or a 6, the fly is labeled C. Any issues with that one?
It might not make even groups.
Alright, so now we're down to C and D. Even number, odd number, container, 16. What does 2 more? I'm not reading something.
Isn't C similar to A?
That's I'm missing something that I'm not reading. Why?
Because it's like the last 20 flies are.
Yes. Okay. So regardless, so the issue with A and B is the first 20 caught are similar in some way, right? C is better than A and B. Group A and Group B are probably going to be a little bit better, but Group C is still going to end up being more of the ones that are the last ones left than any of the other groups by default. Does that make sense? So it's because this, and this is, I've seen this question a lot, and it's usually not asked that way. And so that's why that one's bad. There's nothing wrong with D is pretty much the ideal scenario. You randomly assign them each a number, a name, and something, put those in a hat, and then do a complete simple random sample randomization process at that point. And that one's really picky with C being a little bit different. I think word is funny. At 31. A candy company claims that 10% of its candies are blue. A random sample of 200 candies is taken and 16 are found to be blue. Which of the following tests would be the most appropriate for establishing whether the candy company needs to change its claim? I could write this stuff out. I wouldn't need to for this problem. This is what. How do I use this? What is this? Number of,
Successes.
and I use that to find my. What is this? I'm just like scratching things on paper. If it said that, what would I write for that? At that point, I can pretty much get my answer, but I didn't really need to write all that to get there. What is this definitely not? I only had one sample. So that helps us narrow down a little bit. We talked about this earlier. Anyone that's a chi-square test that's not good as a fit would need to be a what? Which means there are two variables. And that's definitely not the case here. So, do I have anything to do with matched pairs? Good. In a matched pairs, how many variables would I be recording? And you probably didn't need to go through that whole process to figure out that that was the right answer anyway. Number one. Lynn is planning to fly from New York to Los Angeles and will take the Airtight Airlines flight that leaves at 8 a.m. The website she used to make her reservation states the probability the flight will arrive in Los Angeles on time is 0.70. Of the following, which is the most reasonable explanation for how that probability could be estimated? Anytime we are trying to think about how I want to ask this. Yeah. If I flip a coin, there's a 50% chance that it's tails. Everybody believes me with that, right? How would you know that?
Because if you flipped it a bunch of times, 50% of the time.
If I did that same process a whole bunch of times, about 50% would be tails. Same thing if I roll a die. If I have a die and I don't tell you how many sides there are, I just tell you what my result is. We could eventually do it for long enough and then figure out about the probability we think of it being a certain result, right? Us doing the same thing over and over, the same result, whatever we get. So what would need to be done over and over here, or looked at over and over to get that is what it's asking. So by making assumptions about how airplanes work and factoring all of those assumptions into an equation, what does this one not talk about? This doesn't talk anything about what? What is given in the problem that this one does not talk about? If I'm flying into California and I'm flying into Seattle, are those different? Yeah, it doesn't even talk about that at all. By using extended weather forecast on the date of our flight, there's a 30% chance of bad weather, which means they're trying to say if it's a 30% chance of bad weather, that means the opposite of that would mean she's on time. Well, that's not the only thing that's considered there. So which one of these is the appropriate answer? all in the US, all in California, or all that are ones on flights like hers? All that are ones in flights like hers. That's the process that would be repeated or flipped over and over and over to come up with that probability. What is the definition of the word census?
Taking a sample of the entire population.
Taking a sample of all individuals in that entire population. So if I am trying to see if these are a census, I am only concerned in being able to record the population, not being able to record successes here. So for A, I'm finding proportion. What would success be here? For A, what am I deeming as success? So I don't need to worry about this at all to decide if it's a census or not. I need to worry about what my individuals would be. So my individuals would be licensed bicycles on a university campus. B, I wouldn't be concerned with this. What is my success? So I'm only concerned with this piece of this one. What's the only part I'm concerned with for C? What's the individuals part?
Registered students enrolled in college.
What am I concerned with for D?
Single family dwellings in a small town.
And what about E?
Fish in Lake Michigan.
So I'm not concerned with what I'm recording. I'm only concerned with my population. Would it be hard to get a list of all licensed bicycles on a university campus? Why?
Because they're licensed.
Which means they actually already had to do all that in paperwork. What about here?
That's supposed to say sport.
Support. I didn't need that part. Can I figure out population of students in high school? Yes, that's something that's already done as well. What about here?
Registered.
Basically the same thing here. They're registered. What about here? Maybe a little bit harder.
Yeah.
What about here? That's gonna be pretty hard. Usually I think this one's a more missed question. I like this question. I want to talk about all the wrong answers for this question more so than the correct answer. A fair coin is to be flipped 5 times. The first 4 flips land heads up. What is the probability of heads on the next flip of this coin? What does this problem not actually care at all about? The first four flips. It only cares about how many coin flips. 1. And what is the probability that that 1 coin flip lands heads up? 1/2. Your answer is B. I am more concerned with wrong answers for this problem than correct answer. What is this one representing? Now, I understand that that's the same thing as writing 1/2 to the 5th, but this is written as a specific thing that we deal with. What does this represent? This part of the wording of the problem.
Landing the first 4 heads up.
First four were what?
That's it.
And what is this one?
That's it.
Now, this one is actually set up to be a different type of problem. What kind of probability is it to where the first four are something and the last one is something different? There's a specific type of probability. What would we deem a success here?
90%.
So this one is like, and I know that it's the same thing as the way the problem's written. Failing 4 times and then all of a sudden getting one what? What kind of probability is that? Doing it until my first success.
Geometry.
And that's what it's trying to mess you up with on that one. What kind of probability is C? This should be a very obvious thing because the way one of them's written. What does this thing is weird? It's just a number over a number. It's not a fraction. That is binomial. And then this is just, it happens or it doesn't happen, is all that happens there. But these are trying to get you to think of a different type of problem that we do. $36. This one ends up being an easy problem because of the way it's set up. So if I were to look at this problem, I'm probably honestly going to look at all the answer choices before I ever read this problem. Maybe that's the fact that I don't read well, but I'm going to look at what I need to look for before I start looking for it. What's the same with all those answer choices? So there's absolutely no reason to even look at this at all because it's the same for all of them. Well, what's the first thing that's obvious that I need to actually think about?
What's outside?
So this portion right here, well, that's a trigger for me. I know that, how do I get these numbers? And it's either, this is if it is a, and then if it is this one, it's a what? So I can look really quick at the problem and realize that it says it's a what? So, and before I've ever even read the problem, I'm down to three answer choices. So it's the difference in the proportion of non-luxury cars with bumper stickers and with bumper stickers. Now I'm going to look at what's different about these equations. Well, I've got a 250 and a 100, which means the two what are different? The two sample sizes are different. Which is true. What did I do down here? Put them together. We only put them together when? What does it mean by, when do I put those two together? One word. And when do we pull? What? Well, we are claiming that they are the same, which means we are running a... Well, what is this whole problem about? An interval. So this is not pulled. So now I'm down to two answer choices. What is this actually doing? this is actually the same thing as this, just written as a fraction. So I just didn't even read the problem and I know the answer's A. Now, if you read the problem, I should make it a whole lot easier, but I can use context stuff to get you through it. Yeah, we'll do this one as the last one. Okay, 24. This one's pretty easy to look at. Which of the following is correct? And I'm looking at those two graphs. The interquartile ranges are the same. Are the interquartile ranges the same? Yes, no? No, those boxes are different sizes. The range for species B is greater than the range for species A. That's all the way end to end. Are my ranges different? There are more petal lengths that are different. That might not be an obvious one. More petal lengths, more petal lengths. Now I actually have to know if it didn't tell me that the two sample sizes are equal, I could not compare the amount. I could only compare the percents. But because it told me that, I can. So more petal lengths that are greater than 70 for A than there are for B. What percent is greater than 70 for A?
Less than 25.
And what percent is for here?
Greater than 25.
So is that more for A? Greater than 40. What percent is greater than 40 for A?
More than 50%.
What percent for B?
Less than 50%.
So greater for B than for A, is that right? Yes, no? And then the last one, for 30, and it says less than 30. What percent is less than 30 for A?
25.
What percent is less than 30 for B?
Over 25.
So less, more, there are more for B than there are for A. And we'll stop there for today and we'll finish the last few tomorrow.